Hello 108 students, Mr. McHugh here with you. Welcome to section 9.2 where we are going to work with the quadratic formula. Page 1, a rare instance, we're not going to actually do any homework problems. We're going to do a little theory here, and our challenge is this. We learned how to complete the square, and mathematicians said, you know, I wondered if I took the standard quadratic formula, ax squared plus bx plus c equals 0, and solved for x. If I isolated x, what would I have? And maybe that quadratic formula would be a way for us to identify the a, b, and the c constants, put them into a formula, grind out the answers instead of doing completing of the square. Kind of like, hey, let's just do it once, know what the formula is. Okay, now good news, you do not have to memorize this page here. When I first taught this, I did this on the board, and I always get pressed for time, so I'm kind of liking technology now where you can listen to me for the next couple minutes, understand the concepts, kind of get the gist of it, but don't panic and freak out that you have to memorize this. Back in the day when I was in Algebra 2, my teacher made me do this, so we just don't have time to get that crazy. So, look at the steps going down the left-hand side. Step 1. Isolate the x squared so the coefficient is 1. So whatever a is, divide by a across the equation. Okay, so far, no big deal. You get x squared plus b divided by a, x plus c over a equals 0. Step 2, leave only the x squared in the x terms on the left-hand side, so minus c divided by a on both sides. Therefore, you see the minus over there. Now, that's not too bad, and then we've got to complete the square. Now the idea was to take the middle term, which is now a b over a, take 1/2 of it and square it. Do you remember those words? Take 1/2 of the b term and square it. Now it's the coefficient here we're talking about. Okay, now what I did was I showed that work. What's the results? 1/2, 1 times b is b, 2 times a is 2a, quantity squared. Then what I did was I left it on with b divided by 2a on the left side, and then on the right hand side I'd get the results. B squared divided by 4a squared. Does everybody see that? What I did was I put this version on the left hand side and put this version on the right hand side. There's the equal sign there. Okay, the reason I did that is when you complete the square, your goal is to write the binomial squared, which means you take the square root of the first term, which is what? X. Bring down the sign. What's the square root of the third term? B divided by 2a, and you stick it right in there. Okay. Is everybody doing okay here so far? If this just follow along. So I figured out the squaring factor. I put it on. I added it to both the left and the right hand side, but I picked the correct forms to make life easier for me. Okay, now from here, I took b squared 4a squared minus a and got the same common denominator, which would be 4a squared. So I had to multiply by ac on both sides over here on the right, this term. So that left me with b squared divided by 4a squared plus minus 4ac divided by 4a squared. Notice the same common denominators. Okay, so now you get into a little hairy algebra a little bit, but the good news is now I needed to now take the square root on both sides. Remember, our goal is to isolate the x. Sometimes you get all these variables going and you forget what you're doing. You're isolating the x. Take the square root on both sides. You know the drill. Square root undoes squaring. You're left with the base drops down. Okay, that looks a little better. Took the square root on both sides. And 4a squared is under both of them. Take the square root of 4a squared is 2a, so I went from here to here, and I left the square root of b squared minus 4ac up in the numerator. Okay, so you've got plus or minus, and don't forget I took the plus or minus there whenever you take the square root on both sides. Now, last thing I got to do is isolate the x, and so this is where I deviate from the book a little bit, but I subtract minus 2a on both sides of the equation, thus isolating the x and leaving x equals negative b divided by 2a plus or minus the square root of b squared minus 4ac divided by 2a. Now, I use this from my, I taught back in Clearwater Valley and back in '06, and the book used this version, and I'll tell you what, I did not learn it this way back when I was in algebra. I learned it the way that the book did it, which was on page 506, and you can look at that version of it from the book. Okay, their idea is they left it all, you know, the book loves to have everything under one common denominator, negative b plus or minus the square root of b squared minus 4ac. Okay, both forms are correct. I kind of like this version here with the book because it helped understand what a parabola is. Parabola has got a line of symmetry, and that line of symmetry is right here, negative b divided by 2a. You're going to see this more as we move through the chapter, and as you plot, when you find that line of symmetry, this plus or minus is going to give you points on the left side and the right side. Left side, right side, equal distance. Okay, so you pick whichever form you use. The idea now is you're going to write this down in your reference sheet. You do not have to memorize it. You get to 143, they're probably going to make it. But for this class, you just write them down. But write it down for every single time you do these problems. Take the time, do the self-discipline, write the quadratic formula. Then all you're going to do in the problems is you're going to take the values for A, B, and C, and you're going to substitute them in. And then you're going to not do any algebra, but you're going to do plug and chug. Okay, Mr. McHugh here. I think I'm going to sign off here for page 1 to get warmed up here. Study that, okay? Make sure you understand how and why you use this formula. You'll appreciate it, and you'll trust it, and you'll use it, and it won't be just somebody just threw it at you one day and said, memorize this formula and use it. Okay, so Mr. McHugh, wrapping up here. I will see you for page 2, and we're actually going to use the quadratic formula now. And the reason we want this, by the way, is you can't always take a trinomial and do perfect square trinomials. You could, I take it back, you could. Sometimes it gets a little hairy. Reverse FOIL does not always work out. Sometimes you get complex solutions. Okay, a little hint coming down the road. So that's why we're learning this. Okay, I'll see you later. Bye-bye.